My name is Belay, and I'm from DTU National Food Institute. I'm working my PhD on exploring enterococci from biofilm forming enterococcus pathogens to safe food microorganisms. And I'm working with Professor Christian Solom and from DTU Food, and then Ivan Majovic from Chalmers and DTU Biosustain, the Ivan Ivanovic Lab, and Christian Yars from the same institute, DTU Biosustain. So my project is focused on exploring enterococci, which is one of lactic acid bacteria used in food fermentation, because this bacteria has great potential in dairy industry. Like, it has high proteolytic activity, and it produces volatile compounds, which is important for the flavor of fermented food, especially dairy fermented food. So this bacteria is not yet approved for food. I mean, some of the species have been approved as a probiotic, and some of the species are used in food fermentation, especially in cheese ripening. And also this genus is robust because some species are producing multibacteriocins. So this multibacteriocin production capacity enhances the ability to limit the growth of food spoiling microorganisms. So, but the controversies in this area is that this bacteria has some species which is pathogenic because of their capacity to produce biofilm, and also they have antibiotic resistance gene in it. So due to this reason, the use of this bacteria in food fermentation is not, it's controversial in using this bacteria as a starter culture. So my project will plan to see the potential of this bacteria and make it useful and safe for food fermentation. So we can just try to harness its potential and make it safe, and then finally we will have safe food, safe fermented food, which is safe in the case this bacteria is unable to produce biofilm and lacks antibiotic resistant gene. And also it produces, because they produces bacteriocins. Those bacteriocins are important to enhance the shelf life of the food, fermented food, which means it's important. And my project will have 3 phases. The first phase is just identifying or isolating enterococci species from fermented foods, vegetables, and also cheese or different dairy samples. After that, we would like to see its potential, and then we will adapt them by using laboratory adaptive evolution or classical mutagenesis using chemical mutagens. And then finally, we will make them safe and able to utilize in food fermentation, and we will assess their potential and regarding to inhibiting or limiting the growth of food spoiling pathogens or foodborne pathogens or food spoiling microorganisms as well, like E. coli, Salmonella, and Listeria monocytogenes and the like. So in my project, we have collected different samples from different areas, and we have isolated a number of enterococci species. And so finally, the project will end up having a fermented food which is safe and sustainable. Thank you very much.